All right. We are going to be doing derivatives when the x is up in the exponent. So this is where we ended that last chapter. Now you know that a log will knock it down, but I'll give you the steps. So when x is exponent, I always say hit it with a log to knock it down. And we're going to be using log to hit it, knock it down, because that's what we know to find the derivative of is the natural log. So hit it with an ln to knock it down. So that's when x is up in the exponent. So first step, you're going to take the natural log of both sides. Of the equation. Second step, you're going to use log properties to bring the variable down. Properties to bring down out of the exponent. Now what's going to happen is you are no longer going to have just a y equals. So you're going to do implicit differentiation like we learned back in chapter 4. So now we will implicitly differentiate and remember that just means you take the derivative of the y terms, but every time you do a y term you stick y prime with it. So then we're right back to just algebra, solve for y prime. And then last step, substitute for y. And I'll show you what that means. All right, so just examples now. And we'll start easy and work our way up. So number 1, y equals 5 to the x. And we want to do derivative. We're finding derivatives all day. So when you see the x up in the exponent, and this is the only time you have to do that, is take the log on both sides. And I'm going to show all possible steps so I don't lose anybody. So now you can use your log properties when you have, what's not on this one? That log to a power, this is an old one. You can bring that down as a multiple. Oh, no, it's right here. When you have a log to a power, the power comes down as the multiplier. So that means this side's going to stay ln of y. This side will become x times ln of 5. And now we're ready for derivative. So doing derivative here, derivative of ln of y is 1 over y times y prime. And then the x's, if you look at this, there is only one x term here. ln of 5 is a constant. Just like if I had y equals 5x, when you did derivative, it just went to 5. Well, ln of 5 is just like the 5 is here. It's just written after the x. So this is your multiplier. Derivative of x goes to 1. So all you have is ln of 5. So we have done all the way through the third step. We've got the implicit differentiation done. We have to solve for y prime. Well, y prime is here. I want to get rid of this 1 over y. So you need to just multiply both sides by y. So on the left, the y's cancel. Let's not cancel here. Y prime equals the ln of 5 times y. And we want the derivative in terms of x. So that's why I'm saying on this last step, substitute for y. Well, what is y? Y is 5x. So now we can substitute 5x for the y and get our derivative back in terms of x. Done. So nothing too terrible there. Take a look at the next one. Number 2. Function 8 equal to x times 4 to the x squared. Okay, first off, I don't like using the function notation. I just pretend that's a y and I start rewriting it as y. So I'll take the time to do that. Okay, first thing to notice, I do have two x terms, but I have an x up in the exponent. That has to come down before you start derivative. So there's no product rule here. I have to get this down first. So the way I do that is I take the ln of both sides, step 1. So ln of y equals, and you're taking the ln of this product, so use parentheses. Okay, now take a look. The common mistake is people want to take this exponent out here as the multiplier right now. Well, this exponent is only on the 4. It is not on the x, so it can't get past the x. There's a big wall here. So what you have to do is use your log properties to expand this so that this exponent can come down. So when you have the log of a product, that expands to the log of the sum of the two logs. So I'm going to leave this alone. I'm not doing derivative yet, just getting it ready to do derivative. So this expands to the ln of x plus the ln of 4 to the x squared. So now this x squared can come out in front of just this term. So ln of y equals ln of x plus x squared times ln of 4. Now we're ready for derivative on this term, and this term. All right, here we go. 1 over y, y prime. This one's 1 over x. Times derivative of x is 1. And over here, this is not a product rule. There is only an x squared here. See this as a constant multiplier. Pretend the ln is just a 4, but the ln of 4 is a number. So it'll be plus, derivative here is 2x, times the ln of 4 carries along. And now we get it to y prime equals, so we got to multiply both sides by y. Now be careful here. Let's be smart about it. So when I times by y, I got a times by y here. Well, if I was to leave it like this, I would be wrong, because the only thing that's multiplied by y over here is this second term. I need this whole side to be multiplied by y. So this stuff is gone. Final answer, y prime equals, nothing here changes. That whole thing gets multiplied by y, and y is x times 4 raised to the x squared. Now, could you distribute that in there? Yes, but it's not going to get you anywhere, so there's no reason to. So that's your final. Number 3. Okay, throwing some trig at you. Y equals x raised to the cosine x. So again, first thing to notice is that x is in the exponent. I know I've got to hit it with a log to knock it down, so I'll log both sides. Now it is legal for me to take this exponent out in front as a multiplier. And now I'm ready for derivative. Over here, it's just the ln of y, so that goes to 1 over y prime. When I look over here and I want to look at derivative, don't just do derivative times derivative. If you have an x term multiplied by a second x term, that is product rule. And if you don't do product rule here, you're going to lose all the points. So you'll start getting used to seeing that product rule, quotient rule. But here we go. Derivative of cosine is negative sine times the ln of x plus, I'm going to keep the first term, keep the u, times by the second term is 1 over x. I think I'm just going to put that over x. That's the end of the product rule. And now it's just get it y equals, and all I have to do is multiply both sides by y. And then remembering that I have two terms here, so I'll need parentheses. So times by y, times by y. So final answer, everything I've got here, negative sine x ln of x plus cosine of x over x, all times by, my original y was x raised to the cosine x. Okay, and our final one's going to be do it two different ways and show that the two answers are the same. Number 4, we've got y equals ln of 4x minus 7 times x plus 10. It's the ln of that product. Okay, first off, this is not hit both sides with a log. You don't have an exponent with an x value. So this is ready to go for integration. So the first way, we're just going to leave it like it is. And then the second way, we're going to use the log property, expand it, then do derivative. So first way, we're going to leave it like it is and jump right into derivative. So y prime equals. So I'm doing the derivative of a natural log, so I know it's 1 over u. So it's 1 over 4x minus 7 times x plus 10 times the derivative of the inside, which is a product rule. And I know the product rule has two parts, so I'm going to put it in parentheses. So here's my u term. V term, derivative here is 4 times x plus 10 plus, I'll keep the 4x minus 7. Derivative here is 1. And just to keep things lined up. So simplifying, I'm going to distribute a 4. And there's nothing here but a 1, so I can just drop parentheses. So I see a 4x plus 40 here, and then a 4x minus 7, and everything's added. So I'm going to have 8x plus 2 over 4x minus 7 x plus 10. Oh, 33. Look at me subtract 33. Okay, method 2. We're going to start with this original one. We're going to expand it with a log property, then do derivative, and then make it look exactly the same as this. So method 2 is expand first. So log of a product. Log of a product expands to log of the first one plus the log of the second one. So starting with y, because this is not derivative yet. Expanding, we'll have log of 4x minus 7 plus log of x plus 10. Now we're ready for derivative. So doing the first term, because it's separated with an add sign, I'm just looking at this derivative, which is 1 over 4x minus 7. Derivative of the inside is a 4. Same thing here, 1 over x plus 10. Derivative of the inside is 1, so there's nothing there. Okay, so I'm going to have 4 over 4x minus 7 plus 1 over x plus 10. Okay, this answer doesn't look anything like this one. Oops, sorry. Because we haven't brought them together. So we're going to need a common denominator, bring them together, and our final answer needs to be this. Common denominator, remember, needs both denominators. So I'll make my two fractions that I'm making. Both of them need a 4x minus 7 and an x plus 10. Okay, so this one, now I got to fix the numerator. I hit it with the 1. So the bottom got multiplied by the x plus 10. That means the top has to get multiplied by x plus 10. So I'm going to take the time right now to distribute that 4. My new numerator is going to be 4x plus 40. That looks familiar from the top. This one needs the 4x minus 7, multiplying by 1. Now that they have a common denominator, we write that once. Oops, so close. Got an add sign in the middle, so there's nothing there to worry about. 4x plus 4x is an 8x. 40 plus a negative 7. There they are, looking absolutely identical. All right, so just some algebra to keep track of today. You should be okay.